Good day, folks. In today's class, I'll be talking about the Newton's law of gravitation. Newton's law of gravitation. Okay, so you might have heard about this term Fg equal to mg. In today's class, we'll basically talk about from where this term came about. So Newton said that anything which has a mass will try to attract the other things. So if this body, let's say M1, has certain mass, it will try to attract the bodies around it. So if there are two bodies, body A and then there is body B, these two bodies are trying to pull each other towards themselves. So body A is trying to pull body B towards itself, and body B is trying to pull body A towards itself. So that was said by Newton. And Newton also proposed the formula for that. Before proposing the formula, he said that force with which they will pull each other will be directly proportional to the product of the mass of the two bodies. So let's say this is M1 and this is M2. So the product of mass will be M1 times M2. So directly proportional means if the mass 1 is bigger, then the force will be bigger. If the mass 2 is bigger, force will be even bigger. So that's what he said. And he also said that it not only depends upon the mass of the two bodies, it also depends upon the square of the distance between the two bodies. For example, if this is again body A and this is body B, if the distance between these two bodies is R, so one thing I wanted to tell you, the distance is always measured from the center of the two bodies, not from the sides, not from the sides. Okay, if the distance is the r between these two bodies, if I keep on increasing the distance, then the force of attraction will be less. But if I reduce this distance, means the bodies come closer to each other, then the force of attraction will be more. So again, he also said that force of attraction is inversely proportional to square of the distance between the two bodies. And then he clubbed these two together and came up with the formula force is equal to gm1 m2 divided by r square. This is the formula which was proposed by Newton, where g is the gravitational constant, and the value of g is 6.67 times 10 raised to power negative 11 Newton meter square divided by kg square. So this is the formula which was proposed by Newton for the force of attraction between the two given bodies. And based on this formula, scientists came about that Fg is equal to mg, and we'll talk about later in this lecture too. Now, so once Newton proposed this formula, based on this, I'll try to take a random example first of all. So if let's say body A, which has a mass of 70 kg, and the body B, which has a mass of, let's say, 100 kg. So I wanted to find out the force of attraction between the two bodies. That will be equal to Fg gm1 m2 divided by r square. The distance, for the sake of simplicity, I'll call it as 1 meter. This distance between the two bodies, 1 meter. And this value, g, is 6.67 times 10 to the negative 11 multiplied by 70 kgs multiplied by 100 kgs divided by r square, 1 square. Okay, and once we're gonna do the calculation, we will get the answer, and that will be the force of gravity between the two bodies, and the units for this Fg will be newtons. So if I were to do the math, 6.67 multiplied by 70 multiplied by 100, and that's gonna give me 6.67. Oops, not this number. This will be 46 690 times 10 to the negative 11. And then I can move the decimal place from down here. 1, 2, 3, 4. Oops. 1, 2, 3, 4. 4 places. So 4.67 times 10 to the negative 7 newtons. So this is the force of attraction between the two bodies when they are at a distance of 1 meter apart. Keeping the fact in the mind, the body A has a mass of 70 kg and the body B has a mass of 100 kg. One thing I wanted to tell you, this Fg, this formula for gravitational force can be applied to any body which has the mass to it. It is not necessary that it can only be applied to some specific type of bodies. Okay, the only condition is that body needs to have the mass associated with it. Now, coming back to the topic from where we got the Fg equal to mg formula. So in this one, if I look into this formula, this is the mass and the other one is the gravity. Now, mass, if I see this formula Fg, which is gm1 m2 divided by r square. Let's say if I wanted to apply this formula on the earth. So this is earth and I'm standing on the earth. My body mass, just for the sake of simplicity, I'll say 100 kg. That's my body mass is. And the earth's mass, so that will be given to you, I guess, in the formula booklet, or I'll write it down here. Earth's mass is 5.97 times 10 raised to the power 24 kg. That is the Earth's mass. Okay, and distance from the center of the Earth. Again, that will also be given to you in the formula, and or I'll provide you right now in this question. So that is 6.38 times 10 raised to the power 6 meters. Now, if I apply this formula, Fg, which is equal to mass of the earth is, as I said, 5.97 times 10 to the 24 multiplied by number 100 because that's my body mass, and G value is 6.67 times 10 to the negative 11 multiply all of them together, and then the distance is 6.38 times 10 raised to the power 6 square. Notice I could have taken the distance from the center of myself also, but that is very small. 1 meter is almost nothing in front of this distance, so it's not going to make much of a difference. Although in diagram it looks very big, but this is just 1 meter and this distance is 6.38 times 10 raised to the power 6 meters. All right, and once we're gonna do the calculation, you're gonna get certain number. I think that number will come out to be, let me do the calculation, 6.67 multiplied by 5.97 multiplied by 100 divided by 6.38. One more time, divided by 6.38. That will be 97.82, and this is 12. So 24 minus 12. 24 minus 12 is 12. I'm just doing some mental calculation for this question. So this will be 12. 12 minus 11 is 10 raised to the power 1, which is 978.2. And this is the force with which Earth is pulling me towards itself. So Fg, this much Newton. And then if I were to do the calculation for the force with which Earth is pulling me towards itself with the formula Fg, that is mg. And my body mass is 100 times the Earth's gravitational force is 9.81. So this comes out to be 981 Newton. So these two numbers are approximately the same, isn't it? So this G value we can calculate from this formula of force due to gravity, Fg, which was gm1 m2 divided by r square. If I divide this by the mass of the human which is standing on that earth, so this was the question, I am a human being who's standing on the earth. So if I divide it by mass 2, that's going to give me the gravitational pull. g m1 divided by r squared. This m1 is for Earth, this was for Earth, and this was for person who's standing on the Earth. So for example, if you wanted to find out your own gravitational pull, you can put g times your body mass divided by r square. R square will be the distance of that body, or the distance at which you wanted to measure the gravitational field. So if you are standing here, you wanted to measure it at the 2 meters, at a distance of 2 meters. So you can put the R value as 2 meters in that scenario. So hopefully you understood this concept. One more concept before I finish the class I wanted to talk about is that there is a difference between mass and force. Force is always a product of mass and acceleration. In case of Earth, it becomes acceleration due to gravity, mg. All right, so the unit of force is always Newton. Mass is in kg. When I say my body mass is 80 kg, or when we say in layman's language, we say that my body weight is yeah, that's what we said. Our weight is 80 kg. That is actually not the weight. That is actually the mass we are talking about. So the body weight is 80 times 9.81 on Earth. If I was on Mars, then my body weight will be 80 times 3.61, because that's the gravitational pull on the Mars surface. So you need to remember this thing. Although we use the word weight for defining the kgs, but whenever we're using the units kg, it means mass, and mass does not change whether you are on Earth, whether you are on Mars, or whether you are on Moon. So hopefully you learned something from this lecture. I'll see you with another video. Till then, goodbye.